Hi, and welcome to How Do I BI, a many-part screencast series on SQL Server Analysis Services 2008, which is a companion to Smart Business Intelligence Solutions with Microsoft SQL Server 2008 by Microsoft Press. I'm Lynn Langett, a developer evangelist with Microsoft in Southern California. In this edition, we're going to take a look at creating data source views, or DSVs, for SQL Server Analysis Services objects using BIDs. Before we go to the screencast, there are a couple of FAQs and gotchas that we want to review. The first is probably the most important. Before you create any type of SSAS object, and those would include OLAP cubes or data mining structures and models, you have to first create a data source view. Data source views can be thought of as an abstraction layer between the source data, whether it's relational or whatever other type of data you may be using as source data, and the destination containers. In some cases, you'll be the owner of that source data, and you'll create abstractions in that source data. For example, if you have SQL Server, you'll create relational views and then use those as sources. So the data source view will just be simply a pass-through object where no manipulation will be made. In other situations, for example, perhaps in an Oracle source database, you might not have administrative privileges and you might choose to create and enforce abstractions via SQL Server Analysis Services. For this reason, in addition to creating the abstraction, you can also view the data from the source using the DSV capability. Like the other objects in SSAS, when you are right-clicking and using the wizards to create a DSV, you will actually be writing XMLA metadata, which can be scripted for reuse and easy movement from development to production environments. A couple of gotchas and things to watch out for when you're working with DSVs is, just like in any data-driven application, you should retrieve only that information which will actually be used and needed by the destination objects. The general rule of thumb is less data is better. And this is also important in terms of security. The less data that you have to protect, the easier it is to secure. Another important point to remember is that any abstractions that you write in SSAS on your DSV have to be written in a language that's understood by the source system. For example, these should be written in T-SQL if they're going to be executed against SQL Server source data. This is a common point of confusion for BI developers who assume mistakenly that they'll have to write in MDX if their destination containers are cubes, or DMX if the destination containers are mining models, but it actually has to be written in the language of the source data. Before we go to the screencast, I want to highlight a community expert who can help you in your learning about BI. This week's community expert is Ted Malone. He's a SQL Server Reporting Services MVP, and his blog is shown here. And now we'll go to the screencast. In this screencast, we're going to be taking a look at data source views, or DSVs, as worked with in BIDs for SSAS objects. As I mentioned in the introduction to the screencast, every object that you create in BIDs, whether it's an OLAP cube or a data mining structure and model, will require a data source view. Now, how much work you have to do in the data source view is going to be highly dependent on whether or not you own the data sources, and by that I mean whether you have administrative privilege. I have seen in production work that it's quite common where SQL Server, for example, is used as a data source and all the abstraction is done there, and a DSV is simply a pass-through container and there's really no changes made. However, I've also seen situations where the underlying relational data source is something that is not owned by the BI developer, and the BI developer has no privilege to create any objects or make any changes there. So then DSVs are used to create significant abstractions, rename columns, create virtual tables, so on and so forth. One of the things that's important to understand is the data source view will be the source data for the structure in SSAS. Now, the OLAP cubes do expect a certain type of relational structure, and that's called a star schema. I won't be covering that in this webcast. It is covered extensively in my book, which is referenced in the introduction. I'll simply talk about implementing the star schema format in the DSV. Data mining models can be built off of various types of source data. So what I've done here is I've opened up the sample AdventureWorks DW data source views, and we'll take a look at the sample that's used for the cube, which is AdventureWorks DW. Now, when you initially open this, it's a pretty intimidating sample because you have literally many tables, and it's really difficult to even read the diagram. One tip in general in all of these viewers that those of you who already work with Visual Studio might be familiar with is if you click on the little crosshair on the bottom, you can navigate the diagram a little bit more easily. It also has a zooming capability, so if you want to just zoom in so you can actually see a portion, you can click on the zoom capability. Another thing that you can do is you can select a subset of the tables in order to understand the diagram better. So for us to understand this, we're going to take a look at reseller sales, which is in a classic star schema in that there is a central fact table called fact reseller sales that has relationships via primary and foreign keys to secondary dimension tables, which are either single, as in the case of dimension currency, which are called star dimensions, or multiple tables which have joins between them, which are called snowflake dimensions. Now, some of the things that you can do inside of an existing data source view are you can take a look at any of the data that is used as a basis. And why you might want to do that is to understand whether or not you need to include this data when you are going to be creating your objects. So to do that, you just right-click on the object of interest. In this case, we're clicking on the DIM product table, and then click on the Explore Data menu option. And sample data will be loaded up, and then you'll see that you have 4 different views. You have tabular data, you have pivot table data, so you could drag and drop information about the products into a pivot table and quickly and easily understand that data a little bit with a little bit more depth. And I'm just dragging in some sort of random data here. So I've got a product alternate key and a weight and measure code, and I can of course pivot this and filter it and so on and so forth. I can also view this in a chart. And if you're thinking that this looks quite a bit like Excel, that's because these are very similar controls to those that are actually used in Excel. And we also have a pivot chart where we can drag items from the chart field list on. The purpose of this Explore Data section is so that you can better understand the data that you are going to use as a basis for your objects. Now, once you've taken a look at the data, you might then choose to make some changes to the way the data is displayed through the DSV. And what you can do here is you can create new named calculations within your tables, and you can think of these as calculated columns. Again, they have to be in the language that's understood by the source system. So in this case, it's SQL Server. So I'll say test of new column. There is no IntelliSense here, so you have to have tested the syntax in some other environment, because if it is invalid, it will simply fail. And then if you clicked OK, this would just add this as a virtual column to this particular table. Now, in addition to adding virtual columns to tables, you can also create virtual tables, or in essence, views. If you take a look at the tables list over on the left-hand side, you can see the blue icon is an actual physical table source. The double table icon, for example, DIM currency, if you look at the properties, you can see under the query definition, it actually shows you, in this case, the T-SQL query that was used to generate this virtual table. Now, this structure that we're looking at here is the basis for the sample OLAP cube, and as I mentioned, this is in the format of a star schema. In addition to this, you can have data source views that are used as a basis for data mining structures, and that will use a more traditional relational structure if you are pulling directly from relational information. So clustered customers, which is in the examples here, if I double-click that, you'll see that that's a much simpler DSV. It simply has the information about the mining model. It's a single table. So the usefulness for DSVs in terms of manipulation of source data is more frequent in OLAP cubes. In data mining models, it's more of a pass-through type of a situation. Now, as we did with data sources, if you wanted to create a new object, you simply would right-click and then click on New Data Source View, and that would open the wizard, and then you would just click through the wizard as you did when you were creating a data source. You could use the data source that had already been defined within the project, AdventureWorks DW, and it's showing you here the connection information, or you could create a new data source from this particular wizard. We're going to just use this data source again just to demonstrate the steps to create a DSV from the wizard. As I had mentioned earlier, these wizards are generating XMLA, and you can actually script this, and this is done in SQL Server Management Studio for maintenance and movement of DSVs. So inside of here, you simply select the tables of interest, and we'll just pick a couple of tables. If you're feeling like you're not familiar with the data sources, maybe they don't have the friendly names, you can click Add Related Tables and the wizard will detect possible related tables based on similar column names. And then you can filter if you wish, and then you click Next, and that's really all there is to creating a DSV. They're very flexible objects which really have a great deal of usefulness, particularly in situations where you do not have administrative privilege on source data. And do be reminded that they're required for the creation of all destination objects in SSAS. Thank you.